caused by the change in load on the starter motor in case one power source fails and the other one takes over after a short interrupt. It is the flight crew's responsibility to confirm that only a single power source is connected before engine start. During engine start, the electrical system is automatically configured so that only one power source is connected to the bus bar system at a time. This is automatically done when the Start Master is selected on. Again, this only drops one power supply off the bus bar system if two were previously connected. For example, if APU and engine generator are both powering their respective channel and the Start Master is set on, the engine generator is dropped off. Other important changes within the electrical system with the Start Master on are the following. Galley power will be shed and the emergency DC and essential DC bus bars are connected, irrespective of the aircraft's power status. Last but not least, the Start Master On selection powers the starter bus bar, which is confirmed by a Start Power On advisory on the engine's overhead panel. The engine starting process itself will be covered in its own module. Here you have the electrical system set up as you would normally expect it during flight. Both engine generators are online. The batteries are on and the APU is off. We are now moving to the abnormal operation of the electrical system. Let us assume generator 4 fails. The GCU will disconnect the generator from AC bus 2 and the amber generator 4 offline warning will come on. On the generator amp meters, you can see that generator 1 takes the full electrical load. To reduce the electrical load on that generator, galley power is automatically shed as long as only the remaining engine generator supplies the bus bar system. According our abnormal procedure in the QRH, we try to reinstate the generator by selecting the generator 4 switch to off reset and then to on. By switching the generator to off reset, resettable faults within the GCU are cleared. Was this fault resettable? No. As you can see, the generator is still offline after your reset attempt, so the fault is not resettable in flight. According our procedure, the generator has to be set to off reset as the generator 4 offline warning is still lit. Now we perform the remaining read and do items. We reset to TRU1 or 2 circuit breakers if they were tripped, and consider the use of the APU generator as we do not have an electrical backup power source anymore at this stage. Shortly after the APU reaches governed speed, the green APU Power Available annunciator comes on, and the generator is automatically connected to the busbar system when set to on. As you see here, the remaining engine generator supplies its dedicated channel 1. The APU supplies channel 2, and also acts as a reserve for channel 1. Dual generator supply has been restored. Both the engine generator and the APU generator are sharing the load. And partial galley services are available again. No other services are lost. At this stage, we assume that the GCU of the engine generator 1 detects a fault and shuts its generator down. The APU generator will automatically switch from channel 2 to channel 1 in order to maintain power to the captain's flight instruments. Note the AC bus 2 off warning. DC bus 2 is still powered through the DC bus tie system. We would now perform the abnormal procedure engine generator offline, which you already know. The generator is not resettable, so the generator 1 is set to off reset according to the procedure. As already mentioned, we lost AC bus 2, and in turn the first officer's flight instruments, which depend on this bus. The captain's flight instruments and the engine instruments are still available as they depend on channel 1, which is powered by the APU generator in flight. As the APU generator only powers channel 1 in flight, TRU1 is the sole remaining TRU and powers the complete DC busbar system through the DC bus tie system. This can be seen on the TRU amp meters on the electrics overhead panel. Let us now assume that the APU generator also develops a fault. and is shut down by its GCU. The electrical system is now at the essential level. The standby generator comes on. As AC bus 1 and 2 are unpowered. As the APU generator failed, the APU generator offline warning is lit. The main AC1 and 2 bus bars, and in turn TRU1 and 2, are unpowered, so also DC bus 1 and 2 are off, which is confirmed by these 4 amber bus bar failure warnings. As mentioned, the standby generator operates as soon as AC buses 1 and 2 are off. The green hydraulic system is pressurized at 3,100 psi, provided the standby generator control switch is at arm. Operation is confirmed by the white standby generator on caption. The standby generator powers the essential AC and DC buses, and these in turn power the emergency AC and DC buses. Therefore, these bus off warnings remain dark. The battery 1 and 2 no charge warnings come on with a short time delay. This is because the batteries are disconnected from the emergency DC bus to reduce the standby generator load. On a battery amp meter and a DC voltmeter selected to the batteries, you can see that the batteries are not charged anymore and therefore fall back to their normal voltage of 24 volts. According to the Essential Power Level Abnormal Checklist, the APU and engine generator control switches are set to off reset and not attempted to bring online again, as this can affect the operation of the standby generator. Further, the APU is turned off, as the APU generator is unusable and continued APU operation would drain the batteries, and it also saves fuel. Have a look at the instrument panels. The captain's flight instruments and the engine instruments are still available, whereas the first officer's flight instruments are unpowered. Being on essential power level, we now assume that the standby generator, as the last generator resource, fails. As soon as the essential AC bus, which was supplied by the standby generator, fails, the battery contactors close to supply 24 volts DC battery power to the emergency DC bus. The emergency DC bus then supplies the standby inverter with electrical power, which in turn supplies the emergency AC bus with single-phase 115 volts AC power at a constant frequency of 400 Hz. There is no direct indication of standby inverter operation. We are now at the emergency power level. The following indications on the electrics overhead panel have changed. The standby generator on annunciator is out, and the essential DC and AC bus off warnings come on. From the pilot's perspective, very important to know is that only the standby instruments on the captain's flight instrument panel remain available.